Hi there everyone. Welcome to the video lecture series on Taylor and Laurent series in complex analysis. I'm Mayur Gohil. Let us take up now a new type of example to solve about Laurent series. Here is the question. Here we are given the function f of z equals to 1 upon z plus z square, and we are asked to find the Laurent series expansion in these four regions. Okay, so now here you can see there are four regions. Now this question I will be doing into two parts. Let's say I'll call them as part A and part B. Okay, part A and part B, where in part A we will see the first two regions, and in part B we will see the third and the fourth region. Now there is something special regarding the kind of the question I have taken. You can see that in the first region there is 0 is less than mod z less than 1, and in the third there is, I have done it as z plus 1. Okay, so because of that I will be taking that in the different section. So now let us see how to solve this kind of question. So our step number one as usual will be over here, will be to go for the partial fraction of the function. Okay, so we use the partial fraction, so or find partial fraction of f of z. So let us find the partial fraction quickly. So here you have f of z equal to 1 upon z plus z square, right? So when this in this manner, I can write this here. First I'll just simplify a bit, z times z. I can just write this here in this manner. I'll just little bit rearranging the term, and then you get that. Now let us go for solving for the partial fraction. So consider 1 upon z times z plus 1 is equal to a upon z plus b upon z plus 1. So 1 is equal to a times z plus 1 plus b times z. Now you choose some value over here for z. Okay, so I'll choose over here, put z equal to 0. So the moment I put z equals to 0, I get the value of a as 1. Okay, in this equations you put this one. I'll call this equation as, let me call this as firstly I'll call this one as the first equation, and I'll call this in the second equation. In the second equation, put z equals to 0 in 2. Okay, in 2, then a is equals to 1. Now you put z equal to minus 1, then you will get 1 is equals to minus of b. Yeah, in 2 you are going to put. Okay, so you will get 1 equals to minus of b. It implies that b is minus 1. So your partial fraction is f of z equal to, you substitute the value, so it is 1 over z plus, now this b is minus 1, right? So I'll just write it is minus 1 upon z plus 1. I'll just make it little bit nicer in look, so I'll just write here 1. Yeah, just a minute. So you can have it written in this manner. So z plus 1. Yeah, now we are asked to find the Laurent series expansion in the cases that we have. So we will see the first case. Let's go for the first case. So the case number 1 is 0 is less than mod z less than 1. So now what do we do over here? So I'll call this equation as 3, in which we got our partial fraction. Okay, this I'll call this as 3. Now when you have 0 is less than mod z less than 1, remember we have to expand over here in a way that the series expansion that we have seen that works. Okay, so first of all we see everything should be less than 1. Here the meaning is mod z is less than 1. Now in this function f of z equal to the third equation that we see, f of z is equal to 1 upon z, and here I write this as 1 plus z. Now see here, uh, you will have one doubt here, in which part we will do the expansion. Should the expansion happen in the first this part or in this part? Remember, whenever, if you cannot expand z 1 upon z alone, only those parts will have expansion where it is 1 upon z plus a type. Okay, you can see here it is something like this, z plus a or some number should be there. If alone it is there 1 upon z like this, you can see 1 upon z alone, there is no expansion. Okay, you can expand only in the part where you have 1 upon z plus a. This is one important thing to remember. Okay, now let me just erase this off. So expansion will happen only in the second part, not in the first part, remember here. Okay, so we now go for the expansion. The expansion of 1 upon 1 plus z when mod z is less than 1, we have seen there are two ways to write this. 1 upon z, I am going to write the series format. Okay, so the series format for this was summation minus of 1 to the power k z to the power k, k running from 0 to infinity. This is the final answer. Over. If you wish to write the expanded form, I'll give you that too, but this is the answer. That's it. Okay, most of the textbooks give the expanded form, so I'll give you that. The expanded one will be 1 minus of z plus of z square minus of z cube plus and so on. Okay, so that will be the answer. Now this is how it works. So that's it. We don't have to do anything further now. Now let us see the case number 2. Case number 2 is very important, and we will understand now how to handle such kind of case. Let us see. Case 2 says it is 1 is less than mod z. Remember one very important thing here, that we have to make everything less than 1. Okay, the point to remember is to remember where make everything less than number 1, that is less than 1. Okay, so how do I make this now? So how do I make this over here? So let us understand this carefully. What is the meaning from 1 is less than mod z? So meaning 1 is less than mod z, when you say, we have the meaning is 1 upon mod z is less than 1. Now here you remember what is this term? This term that we have got, okay? Here this term, this 1 upon mod z that you got, without mod it looks how? Okay, without mod this is 1 upon z. Okay, without mod this is 1 upon z. We have to establish this 1 upon z in the equation number 3. Okay, so right now, so it is just an understanding part. So without mod z this is 1 upon z, and this 1 upon z is to be established in 3. Okay, that is what we have to do. So let us see how to get it done. So it's very easy now. F of z, I'm writing the answer. Okay, so I'll just put a separator, otherwise you'll make a mistake. Let me erase it off. It's just so f of z is equal to, now see, in the first part 1 upon z is already established, so I don't have to worry about it. It is there. But in the second part it is not there. So how will I get it? So what I do over here, a little mathematical manipulation, take z common. If I take z common, it will become 1 upon 1 by z, right? This is what will happen in the the second part over here in the equation 3. So this is now here. Now we have already seen the expansion of 1 upon 1 plus z. Now observe here, this is just a thing here. I'll take 1 upon z common, and I'll write here 1 minus 1 upon 1 plus 1 by z. Now what do we know about this? 1 upon 1 plus z, we knew the expansion, that was summation. See the case number 1, summation minus 1 to the power k z to the power k. Now instead of z we have 1 upon z, so we just replace it. So here you have 1 upon z, 1 minus summation minus of 1 to the power k, 1 upon z whole raised to k, k going from 0 to infinity over. Okay, now if you want to expand and write all the terms, let us see what happens. This is the answer, this is the final answer. If you leave your answer over here, you will still get the full marks, there is no problem. But if you still want to show some calculations and simplification, you can show. So let us simplify a bit. 1 by z, I keep it outside. 1 minus, now this summation, when you expand, what are you going to get? You will get bracket, you will put, because there is a minus sign, so now you get this expansion, it is going to be 1 minus 1 upon z, right? Then there will be plus 1 upon z square minus 1 upon z cube plus 1 upon z raised to 4 minus, and so on. Okay, it goes on, and then the big bracket is there. Okay, so it goes on like this. So now you simplify it, what happens? Can you see this 1 minus, when you take this minus sign inside, 1 and 1 gets cancelled, all the terms will get a alternating plus minus sign, it will come, and then there is 1 by z outside, right? So you will have, final answer will be 1 upon z square, right? Then because I said there is first sign here, it will become plus, and then there is minus, so here it will become 1 upon z cube and then there will be, yeah, you got this cancel, and here there will be plus of z raised to 4. Okay, so you just go on increasing the power and change the sign. So z square, z cube, right, and then z raised to 4, and it's just shifting ahead. So minus of 1 upon z raised to 5, and so on. Okay, this is the answer. This is the final answer. Or you can leave your answer here also. Both are the same. One is visible little bit, and other one is just in a compact version. You are writing the same thing. Okay, so both here are the two cases that, as I had promised you in this video, we will see these two cases. Understand this very carefully, that what we need in this question is that when the circle, the region that are given to us is 0 is less than mod z less than 1, and 1 is less than mod z. In these two cases I have discussed. I have given here important points to remember in this video. The first point is that, in the case number 2, this is very important. Okay, I'll just remember this point, it's very important. And another thing is that over here, when I explained you that this blue thing that I have written in the part 2 only, again this second case, so this is again very important. Okay, so please remember this. This is what you have to do. If you get this whole logic of fitting up the terms into the partial fraction, your whole business of Laurent series is over. There is nothing much in that. Okay, so this is what we are going to do all throughout the Laurent series. Now for the case number 3 and the 4, okay, we will see how to handle them in the next video lecture. So I hope you have understood these two cases. Please hit like button and share it with your friends, those who find this topic useful, and please subscribe to my channel. Thanks for watching video, and keep solving good amount of mathematics. See you in the next video lecture.